Hello everyone, this is Sriman and welcome to Genius Mathematics. In this video, we will see about arithmetic series and progressions. First, we will see what are series and progressions. Next, we will get to arithmetic progressions and series. First, what are series and progressions? So, series is something like an expression. Let's say we have 3 plus 4 plus 6 plus 7. This is a series because it adds all the constants here. So this is called a series. But if the series, this is an expression, if we need to call this expression as a series, then the numbers in the series should be in progression. Now we will see what progression is. Progression is otherwise called a sequence or a pattern. It can be any pattern. It can be 1, 2, 3, 4, it can be 5, 10, 15 and goes on. All these are patterns. So these are called sequence and there is no addition or any operation in between them. So these are called sequence, patterns or progressions. If the numbers between these operations are in series or in progression or sequence, then they are called series. So that's the difference between series and progressions. In this video, we will see about arithmetic series only. There are many types of series or sequence. They are arithmetic, geometric, harmonic, and arithmetico-geometric. So these are the basic types of sequences or series. In this video we will see about arithmetic series only. First, what are arithmetic series is? We will denote, first we will see arithmetic progression. Let's take 1, 3, 5, 7, 9, 11. This is an arithmetic progression. 2, 5, 8, 11, 14. This is also an arithmetic progression. How you should define or how you should say whether a progression is arithmetic, geometric or anything is, for rule for arithmetic, the thing is we use a term called common difference. That is, this is a sequence or an expression. So if this, let's take this term as term 1, term 2, term 3, term 4 and it goes on. So what we have here is T1 and T2. The relation between these two must be T2 minus T1 equals, let's take another term 2, must be T3 minus T2. That is, the difference between the first two numbers must be the same between the next two numbers. So this is what the relation should be if it is arithmetic progression. If we take this series, we have T2 minus T1 is 2, T3 minus T2 is also 2. This should be followed for all the numbers in the progression. Now next we will take this. Here T1 is 2, T2 and this is T3. T2 minus T1 is 3. T3 minus T2 is also 3. Which means this progression is also a arithmetic progression. So this is the thing about arithmetic progression. And for finding the common difference, we usually take the first term as A, next term as A1, A2, A3 and it goes on. So T1 is A and T2 is A1 or we can define it as any number. Now the next thing is D. D is T2 minus T1 or T3 minus T2. So this the basic thing about arithmetic progression. The next thing is arithmetic series. We have already used this progression of 1, 3, 5, 7, 9, 11. If we just put plus between these numbers, that is like this, then this becomes an arithmetic series. Now, how do we use this is, here we have a and the common difference here is 2. And the number of terms, let's just take the number of terms. We'll just complete with this, finish with this. So the number of terms here is 1, 2, 3, 4, 5, 6. So the number of terms is 6. What if we need the sum of all these terms? That we will represent as capital S. Then the formula for that is n by 2 of 2a plus n minus 1 d. This is the formula for finding the sum of n terms. Before that, what if let's say we have a series that starts with 3 and the common difference is 5. Then find the second term of the series. For that we will use of the series or progression, because we are not calculating the sum. So if we have a equals 3, that is the first term, and the common difference is 5, then what will be the second term? That is t2, or we will write the formula as tn equals a plus n minus 1 d. This is a very important formula for arithmetic progression. So what this denotes is, in this progression, this is the first term, second term, third term, and it goes on. If we want the second term, t2, a we know is 3 plus, for substitute n as 2 because we need the second term. So we have 2 minus 1 and d 5. So 3 plus 5 gives 8. So if a progression starts with a as 3 and it has a common difference of 5, then the next term will be 8 and it goes on. So this is an important formula for finding the nth term of a series. For finding the sum of a series, we will use this formula. Let's take this series. We have found a as 1, as we can see. D as 3 minus 1 gives 2. N is 6, the number of terms. So sum of 6 terms is n by 2, that is 6 by 2 of 2 times a gives 2 plus 6 minus 1 5 times d is 2. So 3 times of 2 plus 10 gives 3 times 12, which is 36. So if we add all these numbers, let's just add them. Let's add these, we get 4, with these 12, add these 2, we get 20, 20 plus 12, 32, 32 plus 4, 36. So this is a shortcut, or this is the actual method to find sum of a series. So this is the basic thing about arithmetic series. So the basic formula for finding the sum of n terms is this, n by 2 of 2a plus n minus 1d. And that's about arithmetic series. Thank you.